Well, let's get started anyways. Okay, good morning, folks. Thanks for stopping in. I know normally I've made Thursdays a office hour day, just leaving it open to you to ask questions. Otherwise, I would take your attendance and dismiss you. However, given the performance on the quizzes yesterday, looking at the purpose of the office hours is, quote, to get additional help as needed. And I am making the executive decision that all y'all needed some, okay? So we're gonna go through the major graph that comprised most of those questions on that quizzes and use that as a holistic example. I think being able to see all the possibilities there together in one unified example will really help solidify it. I know you did well. A couple of you did. Sure, it's not going to take long, okay? So please stick around, and maybe you'll still get something useful out of this. All right, oh good. Perla is now here. Update that. Okay, so as mentioned, the quiz is most of the questions pertained to this specific graph. And this graph is a really useful example because it has every possible combination on it. We've got a discontinuous point, okay? We've got a continuous point, and we've got another discontinuous point. We've got a removable discontinuity. We have a hole in the graph here. So we'll see what the difference is, what happens at each of those types of points. So we'll start on the left. And before we get into that, remember how we describe the graph, that this is literally the left side, this is literally the right side. So when we say evaluate the limit from the left, we mean go from here over. From the left means go this way. From the right means go that way. And always following along the actual curve of the function. Okay. So when a question asks us to evaluate our first limit, limit of f of x as x approaches -4 to the minus -4 from the left, okay, from the negative infinity side of the graph. So it says, I'm going to approach -4, so this is my target area, but I need to find the graph on the left side of it. So it's going to be here, and we're just going to walk along the graph till we get to -4. Where do we end up? This ends up at 3, so the limit from that side, and we'll stick with blue, is 3. Okay. The limit from the right, when it's got a plus next to the number, that's from the right side. So we're still trying to go towards this area, but now we go to the right side of that. Find the graph, here it is. Walk along the graph until we hit x -4. If it helps, draw a vertical line there, vertical-ish. There we go. Okay? So you know as soon as the graph touches that line, boop, there I am. I'm approaching -4. Does it matter that this is an open circle? Not for limits. Okay? Limits are about what are you getting really close to? It's close enough. And this value then is -2. So from that side, it's -2. If there is no plus or minus on your number, it says x approaches -4. Then you have to look at both sides. And this limit only exists if they both match up. From the left, I got +3. From the right, I got -2. Those are not the same number. clearly, they do not match up. And we can look at the graph and say, yeah, There's a total discontinuity there. I will literally have to pick up my pen and continue elsewhere to keep drawing this graph. It's disconnected. The limits do not match. The answer is DNE, does not exist, because both sides do not meet. Now, this is separate from the actual value of the function. Is the function defined at -4? Is there a proper value? If I plug in the actual -4, what will it give me? This is where the open circle and the closed circle do matter, right? Because it is defined to be 3. That's where it's closed. The open circle means, no. The function is not actually defined at -4 because it goes at 3. So the function value there is 3. So that is one possibility, that the function value matches one side limit, but the actual limit does not exist. The full limit does not exist. So if it has a little minus, it means go from the left, and if it has the plus, from the right. Correct. It has nothing, and they don't connect, then does not exist. Correct. If they do connect, then where they connect is the answer. Yes, we will get there in the next example. And closed circle means it's actually there, where open circle is saying close to it. Yeah, closed circle, open circle has to do with the function itself. The limit doesn't really care about the circles, right? Because the open circle is close enough for the limit's sake, but it's one of those like technically correct kind of things. Technically, the function, right, at -4 is 3. But if you're going from this side, it's like, okay, -3.99999, almost -4. Well, then we're going to be almost -2, right? Good enough. Okay. Copy and paste and send it for notes. Sure. Yeah, I can. Once we're done here, I can upload this finished page to Google Classroom. No problem. Okay. That way you have the graph and everything right there. All right. Next up, we have this guy. You know, it would help if I highlighted what we're looking at. Okay, so we're looking at this point, -1. What is happening? Looking at the graph, it looks like nothing special. Okay. Yes, there's a dot there, but it's a closed dot. On the curve, there's curve on either side. The curves are continuous. Okay? So we should get no weird things happening here. What is the limit as x approaches -1 from the left side of the function? So to the left of that, get to my curve, approach -1, I end up at 4. What is the limit as x approaches -1 from the right side of the function? -1 to the right side, find my function, follow it back to -1, I end up at 4 again. Both sides meet, both sides agree. I got 4 and 4 both times, therefore the limit is 4. Also, the function of -1 is defined here, it is 4. So this one, everything matches up. And you could say that about most points, you know, anywhere on this line, that is what we'll get. Again, this seems trivial here. This is the trivial example. There are other cases where it is less trivial. And this is the proper definition of, well, how do we know properly that it actually is continuous? It looks continuous to us. We have that intuitive sense, but as a definition, a mathematical basis on how we can prove that it is or is not has to do with, do these numbers agree? Okay. Next, we will look at +2. So positive 2 we have here and here. That's the highlighter. I wanted the pen. There we go. So first up, limit of the function as x approaches to negative sign. So from the left, so left of negative 2, find our function. There it is. Follow it along. It goes down here to negative 1. So our number there is negative 1. The left side limit is negative 1. How about the right? From negative 2, go to the right, find our function, follow the curve along, back to negative 2, and we end up really close to 5. It's an open circle. Again, the limit is close enough. It's approaching 5. So the right-sided limit is 5. The limit as x approaches 2 overall is what? What goes here? Alex has got it. D and E does not exist. They don't match up. These are not the same number. I had to pick up my pen to continue drawing the graph. They clearly don't meet up. There's a great big discontinuity there. But is the function defined at 2? If I put in 2, will it break the function? No, not in this case. It is defined. They have given us a solid dot. It could be that, both of these were open dots and said, no, we're just going to skip negative 2 and positive 2 entirely. No, they gave it to us. So the function is defined as negative 1 there. Okay. Whenever the two sides don't match up, the whole limit is D and E. Correct. All right, last one. We'll go orange here. Taking a look at positive 4. Now take a good look at that. What's the function doing there? See if you can't predict what we're going to fill in. We'll start with the left-handed side limit as I approach 4 from the left. So left of 4, find our function, follow it back to 4. Looks like I stop at 2. Okay. How about from the right? Go to the right of 4, find our function, follow it back to 4. There it is. Oh, it looks like we hit 2 again. Or close enough. Again, that open circle does not interfere with the limit. We get to 3.9999999 gives me a value of 1.9999999. Close enough, right? Basically 2. These both say 2. So overall, the limit is 2. And the function of 4, if I plug in 4 to the actual function, what do I get? It's not 2. Now the open circle matters. Okay? The actual function value here is not defined. Okay? So this is undefined. Oh, can I squeeze it in there? There we go. The very edge of my paper. Undefined. I wish we could also use D and E, be shorter, but properly we'd say that's undefined. Why is it undefined? Why did it skip? I don't know. We'll investigate that later, looking at an equation for the function, what would cause such a discontinuity. Okay. These guys are jump discontinuities. They're just a result of this function is actually a piecewise function. It is defined in at least 3 separate pieces. This, so I could list that actually, right? Type of continuity. We've got jump and jump, results of piecewise. Here is continuous. Everything matches up. And here we have a removable discontinuity, aka a hole in the graph. Right? The only one we're missing is a non-removable discontinuity. That's the vertical asymptote. Right? That would be if we had one of these guys, right? That's the other option. And for the sake of completeness, let's go ahead and run the limits on that. Let's call this g of x, and I need a number here. We'll go with 3. So the limit as x approaches 3 from the left of g of x is going to be, from the left side, getting closer and closer, I drop all the way down to negative infinity. The limit as x approaches 3 from the right of g of x will be from this side going up to positive infinity. And so overall limit as x approaches 3, are those the same thing? Negative infinity and positive infinity. Those are as opposite as you can possibly be. So it is as does not exist as you could possibly be. And is the function defined g of 3 also undefined? Okay, any remaining questions? Okay, hope that clears things up. As I mentioned, I'll go ahead and post this page to Classroom. You can use that as reference. And so hopefully now everybody can whip up a 100% quizzes retake by the end of the week. Okay, you've got basically all the answers right here. And we'll build on that moving forward.